Okay, yeah, am I audible? Anyone?
Yes, ma'am.
Okay, so we'll start in 5 minutes. Uh, Muhammad Asad, please stop your screen sharing, your whiteboard. Okay.
Good evening, ma'am.
Yeah, good evening. Okay, can anyone tell me how far you have done in week 9? You had one session, right?
No, ma'am. This is the first session.
Oh, week 9 isn't started.
No, ma'am.
When is the deadline for your graded?
Next week, Wednesday.
Okay.
Ma'am, may I know from which week the portion is for December 1st exam, say quiz 2?
Yeah, for quiz 2, the syllabus will be everything from week 1 to 8.
8, right, ma'am?
Yes, 8. First 8
Okay.
weeks.
Okay.
Hello, ma'am.
Yeah.
Ma'am, I have some notes from week 8 graded assignment.
Week 8 graded. Okay.
Yeah.
Yeah, let me share the screen. 1 second. Week 8 deadline is over, right?
Yes, ma'am.
Okay.
No, ma'am. Week 8 deadline was 24.
Graded deadline is 24th?
No, ma'am. 20th, ma'am. It's completed.
It is tomorrow.
And 24 it was extended.
Okay, I'm not sure what is the deadline. If it is on 24th, then we can't discuss graded yet.
Ma'am, I
Ma'am,
got the
it is on
result.
2020.
Yes,
Ma'am,
ma'am. Even I got the result.
Okay, just 1
20
second,
of
let me check.
November.
But I didn't get the result and it is showing that deadline was 24.
Yeah, same for me.
So for some people, the deadline is over. For others, it is showing 24th.
Yeah, ma'am, but how is it is like that?
Yeah, this is not supposed to happen. Let me check once on my
Then
portal what
what's
it's
your
showing.
week 9 deadline? May I know who is having 24th as week 8 deadline?
27.
Yeah, 27.
Okay, so for me on my portal, it is showing that the deadline for week 8 was 20th.
No, how it is
Yes,
like
it is
that? Then
20th.
what?
I'm not sure what the issue is, but let me discuss this once with the team. Okay, if there is some issue like this that for some people the deadline was updated somehow, I don't know. So for now, I'm not going to
Archit
discuss
sir
the graded.
already, ma'am, Archit sir already discussed.
Graded has been discussed.
Yeah, ma'am.
Yes, ma'am.
Yes, we discussed.
Okay. Okay, then I guess we can if it has already been discussed then. But this should not happen. Deadline is same for everyone. Just a second. Yeah, it is supposed to be on 20th only. 24th, it's I don't know how you're getting that. Okay, which question? Week 8 graded.
Ma'am, question number 3.
My screen is visible, right?
Yeah.
Okay. This one.
Yes.
Okay, let me see what the code is.
లేదని చెప్పి ఇంకా డైరెక్ట్ ఈవినింగ్ చేస్తాం
Others, please mute yourself.
ఇప్పుడు కాలేజ్ నుంచి వస్తాం నేను క్లాస్ లో ఉన్నా తిన్నావా మరి తిన్నావా
Okay, so this is a pretty big code, right? So it has 6 maps. So it is saying the following pseudocode is executed using the scores data set. What will be the value of D at the end of execution? So it is NAT type of question. So first, what is D? It is a dictionary, right? What is D storing? So it is a dictionary within a dictionary, right?
Yes,
So for
ma'am.
every key, the value part is also a dictionary. So initially, we have maths, physics, and chemistry as the keys, and the corresponding values are empty dictionaries, right? And B is a variable having value 0. Okay, now we are reading the cards from scores dataset. So first, D is assigned update dictionary field dx mathematics as argument. So what is this update dictionary by field? This is a procedure. So let's first see what the procedure is doing. So you pass a dictionary in the procedure. Y is what? Okay,
Why
Y
is
is the
the
card.
Yes, ma'am.
So subject is you can pass any of the 3 subjects, right? So what it does is if is the key D subject, that means for this dictionary. So D subject, that means like if I pass maths, right? So for math, whatever is the corresponding value that is this dictionary. So this will come and comma city town. Is this bracket correct? Okay, so this entire thing we are finding key, checking whether Y city town is a key of this dictionary or not. So if it is a key, like the person whose card you pick, if that person's city from which they belong to, if that city is already a key of this for this B mathematics, okay, then this will evaluate to true, and then we will enter this if block. Now nested if is again checking if D subject and Y city town. That means this nested dictionary now we are going into. Okay. So inside the nested dictionary, so for D maths, and let's say this person Y city town, whoever's card we picked is from, let's say, Kolkata. So it will be like D math and then nested dictionary here it will be the town, and whatever value is stored in there, okay, that value, and we are checking with y dot subject. So we are comparing these two values. So if y dot subject, that is its subject marks in math, if it is greater than what is stored in that entry in the D dictionary, then we will assign the new value. So basically this, and if it is not, so this else is the else part of which if, nested or outer if? Outer if, right?
Outer if the key is not present
Yeah. So that
in
means
the
if,
city down.
sorry, come again.
Yeah, this else part is for the outer key. If city down keys is not present, then we will create that
Yeah.
key
So if
first.
it is not present, so we'll create the key first, right, with the subject
Yeah.
mark.
Mm-hmm.
So at the end of this procedure, at the end of execution of this procedure, what will D subject city town contain? Like for let's say maths and city town Kolkata, what will the entry contain? What will be the value? That will be the highest marks scored by
Yeah,
any person, right?
highest marks for each city down, I
Each
guess.
city. Yes.
Yeah.
So for that city, let's say there are 5 people from Kolkata who have scored different marks in maths, so the highest marks will be stored, right, in D
Mm-hmm.
dictionary. Okay, so that will, this value, whatever it is returning is, it is returning the dictionary D after updating it, right? So that will
Mm-hmm.
be stored again back here in D. Then again D is updated by, so once it is done for maths, once it is done for physics, once for chemistry. For all 3 subjects, we'll run this same procedure. Okay, and then there is another procedure called eligible. So where is this eligible procedure getting called? Okay, so it is called here. So next you come to line 10. So while table 2 has more, so this one will iterate through the entire scores data set, right, in the first while loop. So after we are done iterating through all the cards, then D will contain what? So D will contain highest marks for each city, right, for
Each
all
city
maths, physics, chemistry.
for all subjects.
Yeah. Now
Mm.
line 10, so while table 2 has more, so now all the cards are moved to table 2. So now you check from table 2. So read the first card again from table 2. If eligible D comma X greater than 1. So this eligible procedure is called here. And the arguments are this dictionary D and X. That is whatever card you pick. So this procedure does what? There is something called a sublist. So this is a list of elements. It has maths, physics, and chemistry. And there is another variable called C, which we assign the value 0. So for each subject in subject list, if D subject city town is equal to X dot subject, that means the person whose card you have picked, if that person has scored the highest marks for a certain city in a certain subject, then you are going to increment C. Like if here, let's say when I come to line 11, I pick the first card, and this person is from, let's say, Mumbai. Okay. Then if eligible D comma X. So I'm passing the dictionary D, which has been updated now, and X, this person's card. And I have to check if it is greater than 1, whatever this eligible procedure returns. So first I will come here, sublist, maths, physics, chemistry, C is 0, fine. So for each subject in sublist. So for maths first we will check. So if that person, whatever that person city town is, right? So if the highest marks for that city town and this person's subject marks match, okay. So we'll check for all subjects. First for maths. So D maths for Mumbai. So let's say in Mumbai city, the highest mark scored in math is 90. Okay. Now this person X whose card you have picked, they have scored 90. So this will be a match and C will be incremented.
Yes, ma'am.
Okay. So like this you have to do for all 3 subjects.
The other person can have it, can be from any.
Your voice is cutting off. Can you come again?
The other person which we are equating can be from any city.
See, whose city we are comparing with? X dot city town. So the city will be same. Right. So for one person only we are checking. So for one card, for every card you are going to call this procedure. So one person can only be from one city, na? So let's say the X card that we picked, that person is from Mumbai. So now we are checking just for Mumbai. all three subjects. Okay. So maths, Mumbai, if that person has scored the same marks, that is the highest marks scored in math from that city, then we are going to increment C. So what do you think can be the max value of C for a single person? We are checking for all three subjects. So let's say this person has
3.
scored the highest marks. Yeah, 3, right? So if this person has scored the highest marks for all three subjects in that city, so for him, C will be incremented thrice, right?
Yes, ma'am.
So that value, whatever is the value of C after we have iterated through all three subjects in this list, so we will return that value. Okay.
Hmm.
Now here you will check. So is the value returned? If it is greater than 1, that means if that person has scored at least the highest marks in one of the subjects in his city, then we will increment B. Okay. So I think, is this based on your, I think you have to go through the scores data set to get the answer to this, right? Because you have to calculate how many times B is getting incremented.
At least in 2 subjects.
So greater than 1. So at least 1 and
Yes.
more than 1 actually.
Yes.
So at least 2 subjects.
Yes.
Yeah.
So then B will be incremented. But to answer this, you have to go through the data set.
Correct. So each city we supposed to check.
Yeah, for each city. So basically the D dictionary will look like this. This is D. So there are 3 keys of the main outer dictionary. Okay. So for maths, let's say we have 5 cities. So within this nested dictionary, there will be one entry for Kolkata. Let's say the highest marks in Kolkata is 90 for math. For Mumbai, the highest marks is 85. Like this 3 other cities. If our data set has only 5 cities I'm talking about, then the next entry will be for physics, right? Outer dictionary, and the corresponding values will be again the highest marks in all 5 cities for that subject. Again for chemistry, like this. Okay. So main thing here is that when will C get incremented? Whenever the person has scored the highest marks in a particular subject in his own city. Okay, and whenever he has scored at least the highest in 2 subjects in his own city, then B will get incremented. Clear?
Yes, ma'am.
Ma'am, just open the scores dataset I have sent you in the chat. And
Okay. Wait, who has sent this?
I have sent Dibbu Majumdar.
Okay. Hmm. So from here now you have to check. Okay. So first what you will do is create that outer dictionary D. Okay. So first see how many unique cities are there. There are 3 unique subjects. So for every subject you have to check how many unique cities are there. Those will be in the inner dictionary. Like if I do for math. So basically there will be the same number of unique cities in all 3, right? Maths, physics, and chemistry. Correct. Because every student
Yes,
has
ma'am.
these 3 subjects. So if there are 10
Yeah.
unique cities, then first you find those cities, unique cities. Now for each city, you iterate through the students from that city and check their marks for particular subject, like for math when you are entering. So first you check all the people from Kolkata and check their mathematics mark and find the highest one and you add it to that dictionary. Okay. And later on, when you go through that eligibility, that procedure, then you just have to check that how many people have scored the highest in what subject in which city. Okay, so basically this data set you have to go. This is a little lengthy. Obviously, this type of question will not be there in your exam. All right. Any other questions from week 8 or should we start 9?
Ma'am, I have
Ma'am,
scrolled down to question number 4 and 6. Just to scroll
yes,
down.
ma'am. Second question before that, could you go? Second question.
Second from graded, right?
Yes, ma'am.
1 second. This one. Okay. This is also from scores dataset only. So I think this is also NAT or no MCQ. Okay, so first empty dictionary D. There is a variable B assigned value 0. Then you go through the data set. Every time you pick a card, you update dictionary by field. So D comma x dot physics. So physics marks of that person and the dictionary D, which is an empty dictionary initially. So what is happening in this update dictionary by field procedure? This one. So you pass an empty dictionary and you pass some student's physics marks. So if that marks scored by that student is already a key in dictionary D, that means what are the keys of D dictionary? Unique marks, right? So if that marks of this student, let's say this student has scored 95 in physics. Okay. So if this is the first card you've picked, so first we pass the empty dictionary and the value 95. Okay. So if it is already a key, which is not possible because D is initially empty. So for first iteration, this will not be true, right? So we'll go to the else part and create this key. So D value is equal to 1. That means at least one person. So there is one person who has scored 95. Okay. So like this, the count of D value will increment. So as many times as you run this procedure, update dictionary by field. So D dictionary will be like this. And let's say these are all unique marks. Okay. These are all unique marks. So there can be any number from 1 to 100. So you have to write the count for each of them. Okay. So how many people have scored 60? How many people have scored 70? How many people have scored 90? In which? In physics. Okay. Because we are only passing physics marks for everyone. So that will happen here. So let's say 3 people in physics scored 60. So it will be 60 is the key and 3 is the value. Okay. This is dictionary D. Then this procedure. Okay. What happens then? Move card to table 2 and B is equal to find key D. So after this is done, after you have populated this dictionary D, then you have to run find a key, this procedure. And you have to pass this dictionary D as your argument, and whatever is the return value will be stored in B. B was initially 0. Okay. So first, when I call this procedure after line 6 is done, we call this procedure. What it does is takes D as the argument. Then there is a variable called key, which is assigned -1. And value is also a variable assigned 0. So for each A in keys of D. Okay. So what are the keys of D?
Unique marks, ma'am.
Unique mark. Okay. Unique physics mark. So for each of
Yes, ma'am.
such value, we have to check if DA is greater than this value. So it starts with 0. Okay. So let's say the first key I pick is this one, 60. So how many people have scored 60? 3 people. So 3 is greater than 0. So that 3 value will be stored in 0 and key will be updated to A. That means key is now what? Key is
60 marks.
60 and value is 3. Right. So D of A. That means this one. 3. So this will go on for how long? For all the keys. So at the end of all the iterations, what is value going to contain? It's going to contain the highest number of or highest frequency of people that have scored the same mark. Right. Let's say I have 30 people in my class. Out of them, 15 people have scored 70 marks. Okay. And all others have scored some other marks. Okay. But 15 is the highest frequency. That means this is the maximum number of people who have scored the same marks. So that value 15 will be stored in the value variable. And key will be the corresponding marks that they have scored, 70. What we are returning is the key. So what is this key that we are returning? This is the marks scored by maximum number of people in physics.
Yes, ma'am. I understood now, ma'am.
Okay.
Got it, ma'am. I wasn't taking X dot physics as marks, ma'am. I was taking it as a subject.
No, whenever it is written dot physics, that means the physics field of this X card.
Oh,
Okay.
okay, ma'am. Okay, ma'am.
Yeah. What other question from 8?
Question number
Ma'am,
4. Question number 4.
guess if 50 students
Hmm.
have got 70 marks and 15 students had got 80 marks, then we can't record 18 as key A.
You're saying that same number of people have scored 2 different marks, and that is the
Yeah.
highest.
Yes.
Okay, let's see what happens if I do that in this procedure. So let's say in this procedure, 70, so out of 30 people, let's say 15 have scored 60 and 15 have scored 70, equal distribution. Now what we will do? So when you come here to update, so what will happen? This value will get updated only once, right? So whichever marks comes first. If 60 comes first in my while I'm traversing through the keys of D, then 60 will remain. If 70 comes first, then 70 will remain because this condition has to be satisfied. So once I get the highest value, then even if I get another same highest value for another mark, it won't get updated. Why? Because there's not an equal to sign here, right?
Yes, ma'am. So it could be greater than or equal to.
Yeah, it could, if it is greater than or equal to, then it will take the last unique mark which has the highest frequency. But since the equal to is not there, so you will take the first unique mark that will have the highest frequency. Usually the distribution will be like that, only one unique mark will have the highest frequency. Okay. But yeah, this is how. Okay, question 4. This one.
Yeah. Ma'am, I want to ask that what is the error in the line 10? Rest of the thing I know, but in the line 10, I'm not able to understand the error
Let
because
me
answer has.
Let me check once what the code is. So following pseudocode is executed using shopping bills data set. At the end of execution, variable D captures following information. So D is a dictionary. It captures for each customer Z. So DZ is a key. So Z is the key basically. And again, that customer, whichever shops they have shopped from. So DZ shop. So this is a nested dictionary, or this is a DZ shop. So why isn't shop in bold? Is this nested or not?
Yes,
Yeah,
it
this
is
is so
nested.
definitely nested. So this should also be in bold. Anyway, so stores the shops visited by Z, and DZ category stores the categories of items purchased by Z. So for every customer, basically outer dictionary D will have keys as unique customers. Okay. So if there are 10 unique customers, 10 different keys for dictionary D. Now for each of those keys, that is for each customer, we'll have another dictionary. There is a nested dictionary in which there are only 2 keys. One is the shop and one is the category, which again have values as list. Okay. So if a person, let's say some person with customer ID C01 has shopped from Big Bazaar and that SV stores. Okay. And they have a category of items, right? So it is saying that DZ category stores the categories of items purchased by Z. So let's say they have purchased some groceries, some stationery, whatever. Okay. So this Big Bazaar and SV store. Okay. This will be stored in the form of a list here. That is names of shops from which this customer has bought things.
Yes, ma'am.
And the categories of items that he has bought will be stored here. So for every customer, there is a nested dictionary, which again has 2 keys, shop and category, which store the value as in the form of lists. Okay.
Hmm.
So now let's see. D is empty dictionary. File 1 is more cards. Shop card you're reading. For every card you're going to update dictionary D. So update dictionary is taking the card and dictionary D. And if the customer key is, if the customer name is not already present, so if it is not is key, then you're going to create the key for the customer. Okay. But this is not correct, I think. Because category, line 10 is giving error, na?
Yes, ma'am. Line 10 have errors, but I'm not able to understand what is the error in line 10.
Let me read the entire thing. So, okay. If not is key, then you're creating key find. And DY customer name shop, Y shop name is true. So if this is not the case, then you will come, anyways, you will come to this line. So this should be under some else. Is this an MSQ? Yeah.
Y dot customer name is in list.
Y dot customer name.
Is in list. It
So
should be
this line is wrong. This
But
line
ma'am,
is definitely
they
wrong.
created a different types of keys, shops key and category key inside the
And
dictionary.
in line and in
Yeah,
line
shop
14,
and
there should be category in place.
A dot category, right? This one you're saying.
Yes,
This one
and
should
there
be
should be
just category. So that's why line
yes.
14 is wrong, but line 10, why is this wrong?
Ma'am, this shop, ma'am, it should be actually marked to a dictionary and not a list.
Because so this person, if okay, if this person has shopped from 2 different shops. So if I put those in the form of a list here,
Yes,
so
that
then
I'm
what will
trying
be
to
the
say.
error?
Ma'am, since we are storing the values as in the form of key value format, so we are actually marking it to true once we find the shop name. So this should be a dictionary, like shop. It should be marked to a dictionary.
One thing is that you are accessing the shop and category as dictionary keys. So if you are marking them as keys, then the corresponding result, that is, this is the value, right? So we cannot access this as a key if it is in the form of a list, the shop name. Up to this, it is fine. This shop we can access, but this is not a key of a dictionary, so you cannot write this syntax. So if
Ma'am,
it is
instead
stored
of
in,
lists, if we made it into dictionary, then
yeah,
we
so
can
this
access, right?
would be, this should actually be like this. So for Big Bazaar, there should be a separate key and it should be true if it has visited that shop, right? Whatever shops he has visited for SV stores, this should be true. Then this key value pair, then you can write in this format, this line 12, then it will be correct. But if it is in the form of a list, then you cannot write because we are accessing them in the form of a dictionary. Yeah, line 10 and 14 are definitely wrong.
Yes, ma'am. Line 14 is wrong because shop is there, right? Category should be there, right?
Yeah, for this one you cannot write like this because this is not a key. A dot category. Up to this it is fine. DY customer name. So you come to this in a dictionary and then shop. So shop stores a list. A list has elements, right? It does not have key value pair. So within that again you cannot write A dot category. This is wrong syntax. So if inside the shop, if it was stored in this format, then I can write, okay, some shop name that is the key.
Yes, ma'am. I was telling, like in category, in line 14, instead of shop, category should be there, right? Then it
Instead
will
of
be
shop, if I write category, then also it is not correct because category is also storing list as the value. Na? So if category is also formatted as a dictionary here, then it will be
yes, ma'am.
correct.
Then how would line 14 be correct if there is
Then
dictionary?
let's say he has bought from category of, so if this is like this, so category. Again, if this is a dictionary in which, let's say, stationery is a category for which there is true, that is, this person has bought some stationery items. Groceries is a category for which there is also true. So now I can write. So so DY customer, you're saying here if I write category, right?
Yes, ma'am. Yes, ma'am.
Then after this I can write stationery. So that is a key. This is okay.
Yes, ma'am. That's the mistake in line 14, right?
Yeah. So if both of these won't work because of this line 10.
Yeah, yes, ma'am. Like because line 12 is right,
L-
we need to
line
assume because line
line
12
12
is
is also wrong. Okay. Line 12 is also wrong because you
right.
cannot write in this way. Y dot shop name. Y dot shop name is not a key. Up to shop, this is a key.
Yes,
Y dot
ma'am.
shop name will be a key if I do this. But since line 12 is not given in your options, Okay,
Yes, ma'am.
that's why it is not marked, but it is also wrong.
Because ma'am, wider subnames can be stored as a list, but not as a key.
Yeah, because if you store it as a list, then you cannot access elements in this third bracket key format, right? This is only applicable for dictionaries.
Yeah.
So if line 12 was in your options, then that should also be marked wrong. Okay. Yeah. What else?
Question 6, a small note from question 6.
Ma'am, question number 3.
Wait, 1 second. I have to start week 9. I cannot discuss more right now. I'll take this last question. Okay, then if there is time after the class, I'll solve rest of them. Anyway, this was discussed in your tier session, right?
But we
From
can
what
this was
credit
then?
not.
solution provided.
Sorry? Solution
Credit
is not
segment
provided.
solution.
Yeah, it is not uploaded yet. Will be uploaded. Okay, following pseudocode is executed using station-wise cards of the train dataset. Consider the dictionary station computed in previous question. Okay, so for this you have to solve 5 first. It's going to take time. The following pseudocode is executed using station-wise card of train dataset. So what is station-wise card? It is basically, it has the information of a particular station, right? What trains come at which time, arrival, departure, on which days, all this information. So at the end of the execution, STN captures the following information for a station X and a day of a week A. So station XA. So this stores what? The number of trains running through X station on day A. Okay. So if I write in this way, that means this is a nested dictionary, right? Station.
Yes, ma'am.
From this, I can tell it is nested. So station X. So if I write for station Kolkata, A is Monday. So this will capture number of trains running through Kolkata on Monday. Okay. So station is initially empty while pile 1 has more cards. Read top cards. Then unique station name will be the keys of stations dictionary. And inside this, you're calling the procedure get info station X. So this procedure. Now we have to fill the code here such that against this station name. So basically, what do I need? I need that for this station, what are the days? What are the unique days on which trains are running? If all 7 days are there on which trains are running, then there will be 7 keys in the inner dictionary. And against each of these keys, that is each of these days, there should be recorded as value the number of trains running on that day. So Monday 3 trains, Tuesday 2 trains, it's like this. Okay, so what will give me that information? That piece of code you have to write here. So this one is, so D will be first like this. So all 7 days you create one dictionary like this, right? Now for each A in train list. So for every train you have to check, and for every day you have to check. So which train on what day? Okay. So if, like say, there is some train with this number 22480. Okay. And you are checking that, okay, for Monday. So if this train runs through Kolkata, if I'm talking about this station, Kolkata station, okay. If this train runs through Kolkata on Monday, then this will be incremented. Like this for all trains you will check, like which all days they're running. So like that, all of these values will be incremented. So this will give you the correct answer in the dictionary that you're looking for, right? But your question is number 6. So this is asking that, so now we have the station dictionary computed. So choose the correct statements based on the pseudocode. So Z and D are empty dictionaries. For each A in keys of station. What are the keys of station dictionary? What are the keys?
Station's name.
Unique station
Station
names, right?
Yeah.
So C is 0, Y is 0. For every iteration, these two variables will be reassigned. Okay. Then D is assigned to station A. Station A is storing what? Station Kolkata.
Days of week.
So days of the week, all days, and correspondingly how many trains running on which day. Right. So that is stored in D, that dictionary, in a dictionary. Now nested for each block, for each B in keys of D. So what are the keys of D? Day. right? Unique days are the keys of D.
Yes, ma'am.
So for each of those days, now we have to check if Y is equal to D equals to D of B. That means let's say for Monday we are checking. So Y is starting from 0. So this will be equal when there are 0 trains running on Monday. Okay, for a particular station. If for, let's say the first A I picked is Kolkata. Now for Kolkata, let's say the dictionary, in a dictionary has, for Monday there are 0 trains and Tuesday, Wednesday, all the information are present. So if Monday there are 0 trains, then 0 is equal to 0. So C will be incremented. But if Monday had 1 train, then is not equal to, then this will not be incremented. C will remain 0. Okay. Then you have to come to this if. These are all within the nested for each, right? Within this. Next, this if is checking if Y is less than DB. So initially, Y is 0. Okay. Now let's say for Kolkata, if Monday has 2 trains running, then 0 will be less than 2. So C is assigned the value 1. Okay. And Y will be equal to D of B. That means Y will be now what? 2. So what will, after this inner iteration is done for a particular station, what is Y going to contain? The maximum number of trains running on some day,
Yes, ma'am.
right? So this will always get updated like this. So maximum number of trains running on a particular day. That will be stored in Y. Okay. And C is storing what?
It will store the how many days have the same number of train, the maximum number of 10. It will store the count of that.
It will store the count of
day.
that. Right.
Yes, ma'am.
Then this you will do for all the stations.
Yes, ma'am.
Then you come to line 14. So this for each, okay, wait. This for each closes here. Okay. Then line 14 is if not is key. Z, comma C. So what is Z? This dictionary. Right. So initially it was empty. This is all still within this outer for each. Okay. This outer for each block ends where? Here. So for every iteration, for every unique station, you have to do this line 14. So if C is not a key of Z, that means Z is initially empty. So obviously we have to create the key. How will you create? ZC equals to 0. Okay. That is the first, that is creation. Now once C is created, that is once the value is assigned 0, then whenever it is a key, that is this condition doesn't work, right? Then you won't do anything. So if C, whatever C's value is, if that is already a key of Z, right? Then will I increment or not? Then you have to
Yes,
come to
ma'am.
this line, right? So ZC
Yeah.
equals to ZC plus 1. So you will increment. Okay, now tell me one thing. Let's say for some value of C, okay, it is already a key for Z. Then will I increment the value or not?
Yes, ma'am. I will increment. We will
So whether it
increment
is a
the
key or not,
Yeah.
it will be incremented because it is outside of the if, right? This line.
Yes, ma'am.
Okay, so what is it asking? Which are the correct statements? So keys of the dictionary, Z is an integer that we know. C is an integer, right? It is calculating that highest number. So this one is correct. And there can be a value C such that Z of C is 0. Is that possible? Because even when first time we are creating a new entry for a unique C value, we are already incrementing it by 1, right? Always it will be incremented by 1. So even if that key appears only once, right, then also the value of ZC will be 1. Will it ever
Yes,
be
ma'am.
0 for any C? No.
No.
So this is wrong. All values of dictionary elements are non-zero. This is definitely correct. All values for this Z, whatever the C is, whatever the keys are, it will be non-zero. It can be 1 or more than 1, right? So this one is correct. number of keys in Z is 8. Is that possible? Can you have 8 keys in dictionary Z? What is C? C can have maximum how many values? Unique values? See the code. What was C? When was C getting incremented? So for each B in keys of D, right? What was B?
B was days.
Keys of
Day, right?
dictionary.
So these Monday, Tuesday, these are one keys.
Hmm.
So what did we check? That if y is equal to dv, that is whatever is the number of trains. If it gets equated, right, then I am incrementing C. And again, you have to come to this if and check if it is less. So obviously, these two conditions won't be satisfied at once. Either this if will work or this if will work, right? Either it is equal or it is less, or it can be more. In that case, we are not doing anything. So C will be first if it is less, then C is assigned 1. If it is equal, then C is incremented. C can have how many unique values? Say this. So C stores what? Maximum occurrence of the max value in dictionary D. How many times the max value is occurring? That means how many times the maximum number of trains are running in a week. Let's say on Monday there are 2 trains running. On Tuesday there are 5 trains running. So 5 is the highest. But 5 trains are also running on Thursday. Right? For a particular station, I'm saying. Then for that station, C's value is what? 2. What can be the maximum value? That maximum number of trains are running on all days of week. That is,
Yes.
even if the value is 1. So that is 1 for all days of the week. So C can have maximum how many unique? 7. Possible value is 7, right? It cannot be
Yes, ma'am.
more than that. So 8, it will never be possible. A and C are answers. See, this type of
And C can minimum store one
yeah,
because at
minimum it
least
can be 1. Yeah.
Hmm.
It's only 1 day of the week it is happening that the maximum number of trains are running. Then
but
C is 1.
but it can't be 0.
C. No, C will not be 0. Like some train is running, right? On every day some train is running. So C is first, C is assigned 0. Okay, C will be incremented. First C will be assigned 1 if there is some dB which is greater than the current Y. So then C is assigned 1 and then C is incremented whenever you get such an equal number of trains. C will not be 0. Wait, let me check once. So if C is 0 and for all days, if Y, so if there is such a station, okay, in which let's say no trains are running. On any 7 days, let's say no trains are running. There is no such station in your dataset. So if you go by your dataset, then C will never be 0. Okay, C will definitely not be 0. But in general, I'm saying if we run this for any arbitrary dataset where there is some station through which no train is running, in that case, will these two conditions ever satisfy? These two if conditions won't satisfy, no? So first, Y is this one. Y is initially what? 0. So D of B, that means for Monday. Yeah, correct. C will never be 0. C will always be 1 or more than 1. Even if it is 0, then also it is getting incremented. So what is the worst possible case? That Y remains 0. And for all days of week, so Monday also 0, Tuesday also 0 trains, Wednesday also 0 trains. So for that, what will happen? For every key is in D, the value is 0. So Y will be equal to dB, right? So maximum it will go up to 7. C will never be 0. It will always be non-zero. Any other case? Any other question?
Ma'am, 91.
Which one?
91.
These are all part questions. Okay, fine. It's already 7 and can I come to this at the end of the class? Okay, I'll have to start some of week
Okay,
9.
ma'am, you
Okay.
can. Now start week 9.
Yeah.
Yeah. Lots of things are there in week 9.
Week 9 is much complicated because graph
Yeah, it
and
will get more complicated after this only, like when you work with the trains data set, especially. Week 9 is there is a very small introduction of the that trains data set at the end, last lecture. This is not complicated. Okay, I'll tell you how to make it easy. See, first thing is that week 9 is about my screen is visible. Okay.
Yes, ma'am.
Yeah. See, in week 9 we have two major things. One is your graph, another is matrix. Okay, we all know what all have heard about these two things. They are interrelated. So any graph can be represented in the form of a matrix. Any matrix can be represented in the form of a graph. Okay. So what is a graph? It is basically nothing but a set of nodes and edges, right? Interconnected nodes and edges. This is a graph. Correct. This can be a graph. If I draw arrows, it becomes a directed graph. So graph is nothing but it is a non-linear. Are you saying something?
Can be it the locus of points, madam.
I'm still not hearing you clearly. It can be what?
Locus of points.
Yeah. See, I'm not going into definitions, formal definitions. I'm just saying what a graph looks like. So graphs can be interconnected, like all nodes might be connected to each other. That's a connected graph, or it might not be. Okay. Graphs are nothing but if we talk from a data structure point of view, it is a non-linear data structure. Graphs, trees is a non-linear. That means there are multiple levels. Nothing like not all the nodes are on the same level. You can think of it like this. So these are non-linear structures. Okay. Data structure is what? Container for data. So graph is nothing but collection of nodes and edges. And we will learn about different types of graph. One can be a directed graph, one can be an undirected graph. What is a click inside a graph? These things we'll learn. Okay. What is matrix? We all know this is the structure, right? N cross N. So we'll learn about square matrix only. Square matrix means number of rows and number of columns are same. So if there are 3 rows and then there will be 3 columns. This is a 3 cross 3 matrix. So every graph can be represented in the form of a matrix. How? What will be the rows and the columns? The nodes. Okay. So if this is node A, node B, node C. Okay. Then I can draw a corresponding matrix like this. A, B, C are the columns and A, B, C are the rows. So let's say this is a directed graph. Okay. Just a small example. So this matrix is supposed to represent, so 0 value will represent that there is not an edge between two nodes. And 1 means there is an edge between two nodes. Okay. And also the direction will matter because I drew a directed graph here. So you can see that is there an edge from A to node A? Is there a self loop like this? No. Right. So if no self loops are present, then A to A, there is no edge. So it will be a 0. Is there an edge from A to B? A towards B. From A to B, is there an edge? No, right? This will also be 0. A to C, there is an edge.
No.
So
Yes.
this will be 1. Again, B to A, there is an edge. This will be 1. B to B,
1.
no self loop. This will be 0. B to C also no edge. This will be 0. From C, there is no edge to anyone. So it will be all zeros. Okay, this is just a small representation of a graph into a matrix. Okay, so mainly here why this is looking a little difficult for you is because the pseudocode for writing how to create a matrix, how to manipulate values within a matrix, that can look a little difficult. Okay, so
It
first,
wasn't mentioning the way you mentioned just now, ma'am. You made it a bit easier now.
yeah, like this is basic, like this is the thing that you're going to learn. Okay, so if you first jump onto the pseudocode, then it will look a little difficult. See, First, a list is what? It is a sequence of any values, right? What we know in list is that there is no random access. We have to traverse the entire list. That's one of the drawbacks. That means it takes a long time to cover. So if I want to find some element in a list, I have to go through all the elements that come before it. But in case of a dictionary, there is random access. That means it will take me the same amount of time to access any key in that dictionary, right? Any value. I can just go to the particular key and pick up the value, but it will take the same time for any key value pair. Similarly, for matrix also, this thing is valid, that I can get matrix representations are like this. See, if this is matrix M, okay, I want to know, okay, what value is stored for M, A, C. So that is row A, column C, is this value. So 1. So like this random access. So I can access any such pair, row B, column A, anything. Okay. So random access is also possible in case of matrix. Now see, yeah, this one. So matrix is nothing but a two-dimensional table. It has rows, it has columns, normal table. If it has m rows and it has n number of columns. Okay. That is how we say that not all matrices are always square, right? We will be dealing with square matrix only. But matrices can be of any order. It can be 2 cross 3, 3 cross 2, whatever. So let's say a matrix has m rows and n columns, then it will be an m cross n matrix. What is a square matrix where number of rows and columns are equal? It is n cross n. This is square. Okay. Now random access to matrix Ij, like I wrote matrix, whatever that name was, M, A, B. So this is random access. I'm accessing a particular value in that matrix by giving its row and column coordinates. So by convention, rows and columns will be numbered from 0. Okay. So what will be the numbering? If there are m rows and I start from 0, then I will go up to what? M minus 1. Right. For J also, if there are n columns, I start from 0. So it will be 0 to n minus 1, 1 less, because we're starting from 0. Okay, so convention is that whenever you're creating a matrix, the rows and column numbers will start from 0 itself. Okay, now we'll implement the matrix. See this code. Okay, look at this very carefully because we'll only do the create matrix code once and then we will just call this as a procedure. Okay. So create matrix is a procedure which is supposed to create a matrix with a given number of rows and columns so that we can give as input. Let's say I want 3 rows and 3 columns. What will it do? First, matrices are going to be implemented with the help of dictionaries. Okay, look. If this is a matrix, so I have row 0, row 1, row 2, column 0, column 1, column 2. Okay, this is a matrix. Some values are there. Now, how can I write this in the form of a dictionary? So for every row, there are 3 different column values, right? For row 0, there are column values at 0, 0, 0, 1, 0, 2. Again, for row 1, column values at 1, 0, 1, 1. There is this position, this position, this position. So for every row, if there are m rows and n columns, so for every row, there are how many values? N values in the columns. Correct. So there are 3 rows here and 3 columns here. So for every row, like this row, in this row, how many values are going to be present?
3.
3. Right. If there are 4 columns, then 4 values will be present. So how can I write this in the form of a dictionary? Let's make the rows as the outer dictionary key. Okay. So I'm writing this dictionary D. Let's make 0, 1, and 2. These are our rows. Okay. They are keys of the outer dictionary. For every row, how many column values are there? Again, 0, 1, 2. Right. Sort of like this. I'm just writing a very rough thing. This is a representation, right, of the matrix. So for row 0, I have 3 different values for 3 different columns. Again, for row 1, I have 3 different values for row 2 also. Is this much clear?
Yes.
Everyone? Yeah. So
Ma'am,
this
once
is
could
what,
you repeat, ma'am?
look, I have 3 rows in my dictionary, in my matrix, right? 0, 1, 2 here, and 3 columns. So for each row, how many columns are there? For
3, ma'am.
each row. So for each row, there are 3 columns, right? So if I want to represent this in the form of a dictionary, this matrix in the form of a dictionary. So as first of all, you can see that it is 2-dimensional, right? There are rows and columns. So obviously it has to be a nested dictionary. Nested dictionary is 2-dimensional. Single normal dictionary is 1-dimensional thing. So whenever I create this nested dictionary, now the outer key, I'm keeping it as rows. So 0th row. 0 is the first outer key. First row, 1 is the second outer key. Second row, 2 is the third outer key. For each of these keys, how many values are present? In the columns, 3 values. So for 0th row, there will be a value for corresponding to column 0, corresponding to column 1, corresponding to column 2. Here, here, and here. Right. For 1 also, first row, 3 values. Second row, again 3 values. So this way can I represent this matrix in the form of a dictionary?
Yes, ma'am.
Okay, anyone has any issues?
So ma'am, you are using the number of rows as a key and
Yeah, like this is very rough. I'm not
oh,
saying
so
that
sorry.
exactly this. Okay, I'm just saying that for
Number of
every
columns as
row,
a key.
number of rows will be what? Outer keys.
Hmm.
Okay, each row is an outer key. And for each of those rows, the column values will be the inner dictionary. Okay, so it
Okay,
will
okay,
be,
okay.
actually it will look like this. Let's see, one example I'll give. So for row 1 and column 2, if the value present here is 5, okay, then in the dictionary it will look like this. So row 1, correspondingly 0 column has some value, 1 column has some value, 2 column will have the value 5. So if I access row 1, column 2, I'll get the value 5. Got it? Clear?
Yes, ma'am.
So we will be representing outer key as
Row and inner key as column. Yes.
that is compulsory, right?
Yes,
Yeah.
ma'am.
So this is what we are following throughout this course. Okay. This is the process we'll follow.
Okay.
Outer keys will be, so you can do the reverse also. That is also fine. Okay. That will also work same way. But usually rows are conventionally taken as the outer keys.
And ma'am, the values inside the inner keys, from where it is comes?
So row 1, that is the outer key, this one.
Hmm.
Now correspondingly, which column value are you interested in? You're interested in this 2.
0,
Right?
2,
Okay.
2. Okay,
So
suppose
come
2.
here and here. So what is the value present? 5. So that will be present here.
Oh, okay, okay.
Okay. See, just now that you've understood this, now the code will look much easier. See, first there is an empty dictionary matrix. That is our this D dictionary. Okay. I is 0. Now rows and columns are number of rows and columns that are present that I want to create. Like if I want a 3x3 matrix, rows is number of rows will be 3, number of columns will also be 3. So I less than 0. As long as I is less than 0, this while loop will run. This loop starts here, okay, and it ends here. So inside this, there is also a nested while. Obviously, I will need 2 loops. Why? Because it is a nested dictionary. Correct. One for the rows,
Yes,
one
ma'am.
for the columns. Yes. So for every row, I will have to go through all the columns. So first I is 0. And I need 3 rows. So this is 3. So 0 is less than 3, fine. Create one key. So mat I will be one empty dictionary. So this is for what? Row 0. Right? This 0 that I created. So this is now an empty dictionary. Okay. Now J is assigned the value 0. Now, how many columns do I want? 3. So 0 less than 3, yes. So now create the first entry inside this empty dictionary for row 0. What will it be? So column 0, right? And I will assign it what? The value 0. Mat ij is equal to 0. I is row number. J is column number. So for I am running this outer while loop for row 0 currently, right? So mat 0, inside this dictionary, this is the J. This is I value, this is J value. This is row, this is column. And what am I assigning in mat ij? The value 0. So this. Okay, now increment J. So in J is now 1. So 1 is also less than 3. Now create the next column for row 0, 1, which is again assigned the value 0. So initially, basically, we are creating a null matrix. It will look like this. All values will be 0. Okay, if this is the 3 cross 3 matrix, row 1, row 0, row 1, row 2, column 0, column 1, column 2. But all of the matrix ij entries are 0. So when I say mat ij, what does it mean? If I write mat 2, 1, that is which value? Row 2, column 1. So here, this value. Understood? So second iteration, this is done. Now j is again incremented. J is now 2. 2 is also less than 3. So make another entry. Again assign it the value 0. Now j becomes 3. So will I make any more entries in this mat 0 dictionary for row 0? Any more columns?
No, ma'am.
Okay. Is everyone understanding? Who is having an issue? Tell me. Anyone?
Ma'am, your question, please ask again. Wait.
Yeah, I'm just asking that anyone who has a difficulty understanding what is
No,
going
ma'am,
on,
the
right?
question which
What the
you
question,
asked.
question?
Yes,
Which
ma'am.
have
Not
Yeah,
yes, ma'am.
I asked that this part are you understanding? Mat 2, 1 means what? Second
Yes,
row,
ma'am.
first column.
Yes,
Okay.
ma'am.
So now j is 2. After this j is again incremented, so j now becomes 3. So 3 is not less than 3. That means I have filled all the column values for row 0. Is this clear?
Yes.
Yes.
This is what I was asking. That will there be any more columns or all columns for row 0 are filled? So all columns are filled for row 0. Right. This is done. Now outer iteration. So now I is incremented again. So now I becomes 1. 1 is less than 3. So now we are creating an empty dictionary for mat of 1. That is first row. Again, for this, you will again iterate through all the j values. See, j is again reassigned to 0. So again, row 1, column 0 will be assigned the value 0. Row 1, column 1 will be assigned value 0. Row 1, column 2 will be assigned value 0. Again, I is incremented. Now I is 2. Again, for matrix 2, same thing. In this dictionary, all the column values. So row 2, column 0, value 0. Row 2, column 1, value 0. Row 2, column 2, value 0. Why all the values are 0? Because see, this entry remains constant, right? Mat of ij is always assigned 0. So I am creating a 3 cross 3 matrix with all values 0. Okay, this type of a matrix is also known as a null matrix, which has all 0 values. Is the creation of a matrix clear? These things that we did here, this will give rise to this dictionary that I drew, right? This D dictionary. The outer, this mat 0 is what? This key 0. Mat 1 is what? This key 1. This one. Who doesn't understand? Tell me. Everyone got it? Clear?
Yes, ma'am.
Others?
Yes, ma'am.
Okay. Then I will not discuss this. Okay. So once this is created, you're going to return the matrix. Okay. That null matrix that we created, 3 cross 3, you return that. So whenever now you want to create some matrix, you can just call this procedure and you can give it the number of rows and columns you want as argument. So if I want a matrix with 30 rows and 45 columns, so this is how you will call it. Okay, and obviously call it inside some variable because it is returning something, so we need to store it in some variable, right? So my matrix equals to create matrix 30, 45. We'll first create a 30 cross 45 matrix. That is 30 rows, 45 columns. And that matrix, it will store in my matrix variable. Okay. See, this is the convention we are following. Outer key corresponds to rows, inner key corresponds to columns. So nested dictionary, outer key is row. For every row, there are nested dictionaries which have columns. Okay. And those nested dictionaries, against each column, the value will be there. That is what value is present for that row and that column. Okay. Now, how do we process matrices? So creation is done. Processing, that means how will we manipulate or perform some task, right? So typically we need to process everything, right? Either we go row by row or we can go column by column. That is our decision. So if I take, let's take the entire code. See. So for each row I of my matrix, for each column j of my matrix, do something with my matrix ij. So first row is what? What is the convention? Row starts from what? 0. Right? Both row and column will start from 0. So for each I of my matrix, so I pick 0. Now come to the nested for each. For each column j of my matrix. So this will run how many times? If there are n columns, it will run. Inner loop will run how many times?
N times.
N times for every row. Right? And if there are m rows, then total how many combinations will be there?
N into M.
M into n, m cross n. Okay. And do something is a procedure. I don't know what I want to do. Okay, now it is saying iterating through the rows. So row indices are keys of outer dictionary. Okay, this we got. Column indices are keys of first of any row. Okay, that means column indices are what? If this is row 0, corresponding to these, there are in a 3x3 matrix, there will be 3 different column entries for column 0, column 1, column 2. So for each R in keys of my matrix. So what are the keys of my matrix?
0, 1, 2.
0, 1, 2. That means the outer keys I'm getting. This in the form of a list. Keys returns in the form of a list, right? So for each, that means start with 0. And for each C in keys of my matrix 0. So what are the keys here? My matrix 0.
First row keys, ma'am.
That means again all the columns. Right?
Yes, ma'am. In first row, right, ma'am?
Yes, first row. For first iteration, first outer iteration will pick 0. For that, we will come to the inner for each block, which will iterate through all these entries and do something procedure, whatever it wants to do with that row and column value. Okay, this is how we will manipulate. Now, why this is sort? This sort, what is the significance? Because whenever we write that keys of D, right, that is we call the key function for any dictionary. So it will return a list of keys, but that is not in any particular sorted order. It will be in an arbitrary order, right? So the keys might be in this order 2, 1, 0. Okay, instead of 0, 1, 2. So we want it sorted because we want to go line by line, right? First row 0 I want to check, then row 1, then row 2. So I am keeping it in a sorted order. So if this keys of matrix, this returns this, then I put the sort function here, that is insertion sorting that we learned. What will this list be converted to? This one, 0, 1, 2, right? So that's why I'm putting a sort function so that I can go from row 0, then row 1, then row 2. Again for columns also, first column 0, then column 1, then column 2. I cannot go arbitrarily. So assume a suitable sort procedure. Usually we'll be using insertion sorting. Okay. And we want it in ascending order. So to improve the readability, instead of writing this, all of this, we will just write rows of my matrix and columns of my matrix. Okay. Which will basically mean this entire thing. So if I write rows my matrix, it will give me the keys, outer keys in a sorted order, right? And columns of my matrix will give me, again, column numbers in sorted order for every row. This much is clear? Right? Yes, no?
Please repeat once, ma'am.
This sort function, did you understand why we use sort? See, when I access keys, okay. Let's say my dictionary has 0, 1, 2 as rows, 0, 1, 2 as column, right? So if I ask keys of my matrix, so this keys will give what? Outer keys of the dictionary. Outer keys are what? Row numbers. So this keys function can return in any arbitrary order. It can return in this order also. These are also keys, right? But in some arbitrary order.
We are
So we are going to
accessing
sort
it
this.
as list, right, ma'am?
Yeah, this will keys function will always return as in the form of list. Whenever we put it on use it on a dictionary, it will always return in the form of a list. Keys of that dictionary in the form of list. But this can give in any arbitrary order. But we want it in sorted order, so this sort function we are putting in front. So this will be 0, 1, 2 after sorting. Why we want this? Because we want to start from row 0, right? Whenever we are manipulating matrices, we always need to maintain an order, that is start from the first row and first column. Don't arbitrarily start. I started from fourth row and third column. Okay. You then don't know what is the next row and next column that is coming, right? For the next iteration. If you sort it, then you know. So that's why sorting function is being used. Now, instead of writing this entire thing, sort keys of my matrix, I'm just writing rows of my matrix because this is returning nothing but rows only, right? Outer keys means row, and I'm just sorting them. So instead of writing this entire thing, just write rows my matrix. Okay, same thing. And for columns also, instead of
Yes.
writing sort keys my matrix 0, write this.
Yes, got
Clear?
it.
Yeah. Okay. Now you can also do this column wise. Okay. So instead of taking the rows first, you can take the columns first. So in this way, what happens? So you first read the columns. So columns can become your outer keys. So just reverse the convention. If you take columns as outer keys, so for every column there are 3 rows. So 0th column, row 1, row 2, row 3. Like this also you can go reverse order. But mainly we'll be following that outer convention. Outer keys will be rows and inner keys will be columns. Okay, any confusion in this creation and manipulation of matrices? Anyone? If you have any confusion, clear it now, okay? Because later on, now we are going to do lengthier codes, right? Okay.
Ma'am,
Yeah,
since for each C in keys of matrix uh, of
0.
first row 0, will it automatically update to when we are changing to sort keys, and after that changing from sort keys to direct to my matrix
Yeah. This will take the
columns?
same thing. Yes. Although it is better to write that my matrix 0, but since it is coming in sorted order only, so see, this first one will return this, right? 0, 1, 2. And for each of this means I will start from 0. Okay. So for this 0, what are the columns? So it will be 0, 1, 2 only. Same thing it will get. Okay. Instead of writing this, you're just writing this.
Understood, ma'am.
Okay. Then let's do the next part. Okay, now we'll do some real-time applications of this. Like, why do we need to do all this, right? Now, if you have gone through the lectures, I don't know how many of you have gone through it. So there is something called mentoring of students, right? Screen is visible?
Yeah.
Okay. See, there are 3 subjects, right? Maths, physics, chemistry. So if you see the lectures, prof is saying that if a student has scored, let's say, some X marks in maths, okay, then who can mentor that student? So we want such a student to mentor this first student so that he is not too intimidated by that other student, and also that that student is still better in studies than this one. So we kept a margin like any person who has scored 10 to 20 marks greater than this person can mentor him in this subject. So let's say student A has scored 60 in maths and student B has scored 75. So what is the difference between them? 15 marks. So this is within the 10 to 20 scale. So B can mentor A. Okay. Similarly goes for physics and chemistry also. So the difference must be between 10 and 20 marks. Okay. Less than 10 or more than 20 is not allowed. Then they cannot mentor. So this is the basic idea. Now, how do we create such a mentor? Like we want to have all this mentor data in a dictionary. How do I create that? So what happens here is that we have to create a dictionary for marks in each subject first. So we need to know that, okay, what marks have been scored in this math subject, right? So let's create a dictionary called maths marks. Okay. So maths marks is a dictionary that will store the marks of all students in maths, right? If there are 30 students, so 30 unique keys and corresponding values will be the maths marks of them. Now read marks. Now this procedure, read marks, what does it do? Like how we are creating this dictionary, math marks. So read marks takes a subject as parameter. Let's say we are passing maths. So first marks is an empty dictionary, then you go through all the rows. So once you pick a row, you do this. So create the key for that sequence number of that student and correspondingly enter his value, right, for that subject. So if the key for this student is say 001, so 001, let's say this person has scored 90 in math, right? So maths marks dictionary will have entries like this: 001 is 290, 002 is 265, whatever maths marks are there. Is this clear? Read marks procedure. Just we are storing the marks of every student in some particular subject. Okay. And we are going to return this dictionary at the end we create. All right. So we have to do this for all three subjects: maths, physics, chemistry. Now create a mentoring graph for a subject. Okay. So how do I create that mentoring graph? Now this is where it gets a little tricky. See. First, we know how do we represent a matrix that Mij. If the value stored in Mij is 1, that means there is an edge from I to j, like I said in the beginning. If there is the value is 0, that means there is no edge. Okay, we are talking about undirected graphs here till now. Okay, undirected means there are no arrows. Like if this is A, B, C, A and B have one edge, A and C have one edge. Okay, so if I try to represent in matrix M, so matrix M, A, C, this will have entry 1, right? Because there is an edge between A and C. But matrix A, B, C, this will have entry what? Is there an edge
0.
between B and C? No. So 0. Okay. Now come to the create mentor graph. So it is taking some dictionary as its parameter, right? What is this marks dictionary? So this can be for any subject, right? Like for maths, we created some dictionary, marks. Now that dictionary I'm passing here. So what is happening? Now, what does marks dictionary contain? All the sequence numbers of students and their corresponding marks in that subject. Like this, right? So how many unique students are there? How can I get the number of unique students? By finding the number of keys, right? What are the keys? Sequence numbers of students. So if I want to
Yes,
find
ma'am.
how many unique students are there, you just get the length of the keys. That is how many keys are present. So that length of keys I'm storing in variable n. That means this many students are present, unique students. Now mentor graph. So mentor graph. So if there are n students, okay, what should be the order of my matrix? N cross n, right? If there are 3 students, okay, then one student has sequence number 0, one has sequence number 1, one has sequence number 2. Okay. Now if, so no student will mentor themselves, right? So 0 to 0, what will be the value here? 0. Let's say 0 is mentoring 1. So here the value will
Along
be
the
1.
diagonal, everyone will be 0, right?
Yes, along the diagonal, everyone will be 0 because no one can mentor themselves. If 0 is not mentoring 2, then it is 0. If 1 is mentoring 0, then it is 1. But if, will it ever happen that, first tell me, is this even correct? If 0 to 1, I'm writing 1. Okay, if this is an undirected graph, then it is okay. But when we are talking about directed graph, okay, that means if 0 is mentoring 1 in a particular subject, That means 0 has scored more marks than 1 in that subject, right? Between that 10 to 20 difference. So if 0 is mentoring 1 in that subject, can 1 also mentor 0 in the same subject?
No.
No, ma'am.
So this should be
No,
0,
ma'am.
right? So if 0 to 1, there is an edge, directed graph. Then 1 to 0, there should be 0, right? So 0 is mentoring 1, but 1 cannot mentor 0 in the same subject. Maybe 1 is mentoring 0 in some other subject. But here we are checking for a particular subject. Okay, let's say for math. Now come to the codes. The mentor graph, create matrix n cross n. So there are n distinct students, so the matrix will be n cross n matrix, n rows, n columns. Now for each I in keys of marks, what are the keys of marks? Student sequence number, right? These. So first sequence number is, let's
Yes,
say,
ma'am.
001. Yes. Now again come to the nested for each j in keys of marks. What is the first j? Again 001. Okay, but the difference in marks will be what?
0.
Difference in maths marks for the same person will be 0, right? So now I have to check ij mark diff. This is storing the difference in marks between I and j in that particular subject. So if this is obviously going to be 0 for one person if I and j are both same. Now ij marks diff. If it is less greater than equal to 10 and less than equal to 20, that is between 10 and 20, then only I can say that I can mentor j, right? But if it is 0, then this condition is violated. So there is no chance of mentoring. That means this remains 0. So whenever we create a matrix, what are the values that are initially stored in all the slots? All the ij values are 0 initially. Create matrix, we saw, right? That procedure. When we are creating a matrix, all the values are assigned 0, right? Initially.
Yes,
Yes,
ma'am.
ma'am. Yes, ma'am.
So now let's say for the next iteration. So now inner j will change again. Next say next student is 002. Let's say. So let's say 1 has scored 90 in math and 2 has scored 75 in math. So what is the difference? 15. So ij marks diff will carry what? 15. Marks of I minus marks of j. This is going to take the absolute value. Okay. If this condition satisfies. So for 15, this condition will be satisfying, right? 15 is greater than equal to 10 and less than equal to 20. So then I will assign one value to mentor graph ij. That means I is mentoring j. So that slot will have a value 1. Okay. If not, then it will remain 0. Because initially the matrix when we created it was having all zeros. So now for all such ij pairs I will see. If there are 5 students, let's say, then how many such ij pairs will be there? 25? 5 cross 5? Right. If there are 3 students, then how many ij pairs are there? Mentor graph ij, how many such unique pairs are there?
9.
9. 3 cross 3. So similarly, only those ij values will be 1 where I is mentoring j, and that is based on this marks difference. Okay. So after this is done, after all the iterations are done, mentor graph ij is updated for all the values that required it. Then now I have a mentor graph where everywhere where row I is mentoring row j. Okay. That will be for obviously I not equal to j. So that slot will be what? 1. Everything else will be 0. Wherever I is mentoring j, that ij slot will be 1. Is the mentor graph creation clear?
Yes, ma'am.
Yes, ma'am.
Ma'am,
Yes, ma'am.
small ambiguity.
Hmm.
Since we're doing it for mathematics, so may I know where in the procedure also it's not written maths, right, ma'am?
Yeah, right. It is written marks. So I just said that this is for math. If I do, then it will be like this. It can be for any subject. Okay.
Like,
This marks
like,
dictionary
is it
will work
only
for
for each subject only we can do it for one
right,
matrix,
right.
right?
Yes,
We
each
can't
subject will
include
have a particular.
three subjects, right?
No, because it
Oh,
can
okay.
happen, right? That I mentors J in maths but not in physics. Then how will you assign the value 1, right? So for every
Yes,
subject,
I
there will
was
be a separate
having
mentor
that
graph.
ambiguity because Marx was only mentioned. I was
No,
having
Marx
that.
is the dictionary can be for any subject. Okay, this is in general it is written. Okay, this part is clear, everyone? Any doubt? Mentor graph. Okay. Now we are going to pair students. Okay. So now till now we have seen how I can assign a mentor to a student. That is that marks difference should be between 10 and 20, and in the matrix format I can just put the values 1 wherever I is mentoring J. So that matrix Mij value should be 1. Okay, now we want to pair. So A can mentor student B in one subject and B can mentor A in another subject. If this is the case, then like let's say if I have one mentor graph for maths in which Mij value is 1, and I have another mentor graph for physics in which Pji value is 1. That means in maths I is mentoring J, in physics J is mentoring I. If this is the case, then I and J can be a pair. Understood? What is pair? So one student is A is mentoring B in one subject, B is mentoring A in another subject. So then A and B can be a pair. Okay, now we have to write the code for this. See. Study groups in maths and physics. So create mentoring graphs for each and use the mentoring graphs to pair of students. So we want to create some study group with people who mentor each other in maths and physics. So what are the steps? First, we have to create the marks dictionary. That is one dictionary, this maths marks will store what? Sequence number is to maths marks of all students, right? That is the key value pair. Sequence number is the key, maths marks is the value for all students. That will be stored in maths marks dictionary. Physics marks will be sequence number is to physics marks for all students, right? These two. Next, I'm going to, with the help of these two, I'm going to create the mentor graphs for the particular subject. So just call this create mentor graph procedure with maths marks dictionary as, see the, whoever was asking this. So whenever we are calling mentor graph procedure, then we are mentioning for which subject we want it, right?
Okay, I mean, now I understood.
Yeah. So
Yes.
similarly, we will create the mentor graphs for maths and physics. Okay. First 4 lines is that only. Now, paired is a dictionary. Okay. What is this storing? So for each I in rows of math mentor graph. So if there are, let's say n students, how many rows in math mentor graph? N rows. Okay. So for each I in rows of math mentor graph, for each J in columns of math mentor graph. So let's say the first I is some student with sequence number 001. And obviously same student cannot mentor themselves. So let's pick the second J, that is 002. So if math mentor graph IJ, that means math mentor graph 001, 002 is equal to 1. That means 001 mentors 002 in math, and physics mentor graph 002, 001. That means 002 mentors 001 in physics. If these two conditions are true and not is key paired I. So this basically means what? That I and J are not already keys of dictionary paired. So instead of writing it like this, if you see the, one second. Yeah, so instead of writing like this, we can write not is key paired I. That means I is not a key of paired dictionary. That means no one has been paired with I yet. Same is true for J, that no one has been paired with J yet. That means they're both available. Then paired of I will have J as the value and paired of J will have I as the value. So I has been paired with J, J has been paired with I. Are the conditions clear? How this happened? Do you want me to explain this again? Anyone?
Yes, ma'am.
At
Ma'am,
dictionary, it
we have
will look
not
like
done for physics mental graph, right, ma'am? Like we
We have to check for
simultaneously,
both maths
like
and physics.
we have done previously
Yeah.
physics mental graph. Okay. Oh, sorry. Yeah, now I got it. We have given create mental graph. Right? Sorry.
Yeah. See what is happening. I'll explain again from the beginning once. First, look. What is my goal? I want to create a study group with such people. So I want such pairings where, let's say, I and J are two students, where I is mentoring J in some subject and J is mentoring I in some subject. Understood? Two separate subjects, maths and physics. So this is my goal. So paired dictionary will contain, what will be the keys of paired dictionary? All students, all unique students, and corresponding value will be what? If paired is the dictionary, okay, then if I is one student sequence number and this student is paired with J, so his value will be J. Again, correspondingly for J, the value will be I. So they make a pair. Okay. This is our goal. We want to find such pairs where I mentors J in some subject and J mentors I in some subject. So for that, we need the mentor graph for both maths and physics. And to create the mentor graph, we need the marks in both subjects for all students. So first two lines, what is happening? Maths marks. This is following the read marks mathematics, this procedure, which we just saw. What does it do? What does read marks do? This will create a dictionary with sequence numbers, unique sequence numbers of all students as keys, and corresponding values will be what? Maths marks scored by the students. Physics marks will be the same thing, just for physics. So physics marks will contain a dictionary with sequence numbers as keys and corresponding physics marks as values. Clear? Now based on this, after physics and maths marks, these two dictionaries are created. Now pass these through the mentor graph procedure. And you can create the mentor graph for math and mentor graph for physics. Mentor graph contains what? Only those entries will be one. Those ij entries will be one where I mentors j. Okay. So if if row 2 and column 3, that means for maths, I'm saying, let's write math mentor graph. Row 2, column 3 has the value 1. So can I say that the person whose sequence number is in row 2 is mentoring person whose sequence number is in column 3 in math subject? I can say this, right?
Yes,
From the
absolutely.
mentor graph. Similarly, for physics also, I can say the same thing. So I created the mentor graphs for both subjects. Now I am creating an empty dictionary paired, in which this is my goal. So I need to find the pairs. How will I create all the pairs? I need all the rows. Okay. So from this line, for each I in rows of math mentor graph, instead of math mentor graph, you can also take physics mentor graph, because the rows, the keys are actually same. Okay, because all students, so the student list is same for both subjects, right? So anything you can take. So rows of math mentor graph will be all unique sequence numbers of students. So let's say for each I, so first I is 001 student. And for each J, so first J will be 001, but obviously a student can't mentor themselves. So let's take the next J, that is 002. Now what you will check, you have 001 and 002 as your I and J values. So come to this if math mentor graph ij is equal to 1, that means 001 is mentoring 002 in math. And physics mentor graph ji is equal to 1, that means 002 is mentoring 001 in physics. And what are the other two conditions? That I is not already paired with someone. That means I is not yet a key in the paired dictionary, and J is also not yet a key in the paired dictionary. If both of them are available, then you can successfully create a pair between these two. So now paired dictionary will have two new entries for keys I and J, for which I will have the value J and J will be assigned the value I. That means I is paired with J, J is paired with I. Clear this code?
Yes, ma'am.
Everyone, right?
Yes, ma'am.
Okay. Now see, one more concept is of popular students. Okay, who are popular students? Students who can be mentored by many other students. Okay, so basically students who are mentoring some students and who are also mentored by some students. So let's say there is some student who has scored 100 in math. Okay, so basically that person can score all students in math. Okay, except those who are 90 plus. They can score anyone else. They can, they can mentor anyone else. Right. So obviously there will be no incoming edge for these students, right? Can these students be mentored by anyone? If someone has scored 100 in math, can anyone else mentor them in math? No, right?
No.
Because what is our criteria that the mentor should have 10 to 20 marks higher in the subject. So if someone has scored full marks, there is no scope for that. So basically there will be, if you see the video, this will be clearer that we will pick those students who have scored a moderate marks, like 60, 70, this type of mark. Okay, so they can mentor people and they can be mentored by people. So these students will have more chances of being popular. That means they are more connected to other students. Is the concept clear, popular students? Okay. Now, how will I find such students? Now, where is the code for this? What? This one. First, we have, let's do this first. A student who can be mentored by many other students is popular. So create mentoring graphs for all three. Okay, first of all, let's create mentoring graphs for physics, chemistry, and maths. Okay, first we read the marks in these three and then create mentor graph for all three. Okay, maths, physics, chemistry. Next, after this is done, now count incoming mentoring edges. Please mute yourself, HP. Okay, see. Now our criteria given is what? That student who can be mentored by many students is a popular student. That means he has many incoming edges. Incoming edges in the sense what? If this is my graph, if this is my matrix, okay. So I'm drawing this for math. Fine. Just for one subject I'm showing now. So let's say there are 4 students, 0, 1, 2, 3, 0, 1, 2, 3. Now this, for this second student, okay, all 4 rows have, except obviously 2, everyone else has 1. That means this person too can be mentored by all 3. So this person becomes a popular student. Okay, what will be the graph representation? This is one node, this is one node, this is another node. These are nodes, right? And all of them will have edges with 2. All of them can mentor 2. So these are what? Incoming edges. Incoming, how do I know? By the arrowhead. Okay. So we have to count such incoming mentoring edges for each student. So the person who has the maximum number of incoming edges is the most popular person. Clear? Is the concept okay?
Ma'am,
Hello,
could you go
am I
2
audible?
steps back? From this code, could you repeat once? Previous page was understandable. From this page.
See, I didn't go into the code yet. I'm just saying that let's say I want to find who is the most popular student in maths, just maths. Okay. So according to our rule, it is saying that a student who is mentored by many people is popular. Okay. So what are incoming mentoring edges? I said that let's say in maths, I only have, let's say, 4 students in my data set. So I have these 0, 1, 2, 3, 0, 1, 2, 3. These are 4 students. So if for the, what is the mentoring graph? What does it look like? Which entries have 1? Where there is an edge from I to j. That means I mentors j. Right? So if 0 mentors 2, then there will be a 1 here. If 1 mentors 2, then there will be a 1 here. 2 cannot mentor 2, but 3 can mentor 2, then there will be a 1 here. So I can see that for 2, everyone can mentor 2, right? So now if I write this in the form of a graph, it should look like this. all nodes are pointing to 2. That means there is an edge from every node towards 2. So these are incoming edges. Why? Because the arrowheads are pointing towards 2. So I am coming from 0 to 2. That means 0 can mentor 2, 3 can mentor 2, 1 can mentor 2. So these are all incoming mentoring edges. So the person or the node which has the maximum number of incoming mentoring edges is the most popular person. Is this clear?
Yes, ma'am.
Okay, everyone, right?
Yes, ma'am.
Yes, ma'am.
Now the popularity matrix is an empty matrix. Okay. So for each I in keys of maths marks, what are the keys of maths marks? Sequence number of students. Maths marks contains what? Sequence number is to mathematics marks for every student, right? So we'll go through every sequence number. What am I checking? So first I, what is I? 001 first student sequence number. Now I'll create an entry in popularity dictionary. So popularity 001 is initially assigned the value 0. That means 0 incoming edges till now. So we are considering that initially when we make an entry in popularity dictionary, no one is mentoring this student. Now you check the inner for each blocks. So for each J in keys of maths marks. Okay. So what is the next J that I will get? 002. Obviously same student cannot mentor himself.
Ma'am, there
So
is another dictionary created for I, right, ma'am? Inside. Or sorry. Yeah.
No. For I there is no
I
dictionary.
is
So
a
for
key
I,
value, right?
yeah, this 0 is the value stored. I is the key, 0 is the value.
Okay.
Okay, this I is 001. Now the next J you pick is, let's say, 002, the next student. So now you are checking what? Math mentor graph. If there is an edge from J to I, that means if J is mentoring I, if 002 is mentoring 001, if this is the case, then there will be a 1 entry, right? In that slot. Math mentor graph JI will have a 1 entry. If this is true, then popularity of I will increase by 1. That means one person is mentoring I. Similarly, check in physics. If there is an edge from 002 to 001, if 002 is mentoring 001 in physics also, then popularity increases again. Okay, so like this, you will check for all 3 subjects. Okay, at the end, in the popularity matrix, the value stored against I will be what? Total number of mentors that he has, right? Is it clear
Yes,
for
ma'am.
you?
Yes, ma'am.
But what is the
Yes.
catch here? Will it give the number of unique mentors he has? No. Because there can be one student J who is mentoring I in all 3 subjects. So that student is counted thrice, right? Because all these if statements you have to go through for each J. So if some J is mentoring some I in all 3 subjects, so for that particular J, how many increments are there? 3, right? So we need to find a way in which we can get the unique mentors. So how that can happen? See, avoid duplicates. So explicitly keep track of mentors for each student and count them. So even if a person J is mentoring a person I in all 3 subjects, we will increment the popularity by only 1. Okay, that means this person is mentoring this person. I don't care in how many subjects. I want unique number of mentors for I. Okay, so how that can be achieved? See, now I have 2 different dictionaries. One is mentors, one is popularity. Okay, so for each J in columns, now I'm starting from columns. So for each J in columns of math mentor graph, so what is the first J? Let's say it is 001. So now you create, this is the mentors is what? A nested dictionary. So mentors 001. For this key, there is a nested dictionary created. Okay. Now for each I in rows of math mentor graph. So let's say this I is 002. So you check, is there an edge from 002 to 001? If yes, then I will store what? 002 is to true. Again, if there
Ma'am,
is
here in this case, 001 is mentoring 002, right?
002 is mentoring 001. J is mentoring I.
Ma'am, you have taken 002 as I, right?
Wait, 002 is the I. Yes. Yes, 001 is mentoring 002. Correct. This is 001. This is 002. Okay, whatever
We
is
are
the
actually
second
doing
one.
it reverse process, right?
Yeah. Any way you can do it. You can take rows first or columns
Yeah,
first.
yes,
It
ma'am.
will give
Like
the same
before
value.
we were doing it
Yeah, rows
in
first we were doing. Now it is columns
direction.
first.
Yes, yes.
So the main thing is that mentors Ji or Ij, whatever it is. If I say mentors Ij is true, that means I is mentoring J. Okay. So if this is true, that Ji, so that means J is mentoring I. So if 001 is mentoring 002, then there will be an entry true here. See, I have removed the increment part. I have just kept true or false. Okay. Either it will be true or not. So if that same person also mentors him in physics, that is 001 is also mentoring 002 in physics, I'm not incrementing the value. This will remain true. Okay. Now for some other for some other I, let's say 003, I also see that 003, okay, 001 is also mentoring 003. So for that also I will keep a track in the inner dictionary. So instead of just doing that increment, if I keep a true value, then I will get unique number of mentors.
So
Understood?
the true value won't be duplicated many times, right?
No.
You are saying.
Yeah.
You
To
are
avoid the duplicates, we are doing this. Because if
okay.
the same person is mentoring one person in 3 subjects, so previous code, here we were incrementing popularity every time this happened. So if one person I was mentoring one person J in 3 different subjects, then for that one person only 3 times this value was getting incremented, popularity I value. When in reality it should have been 1 because this is a single person. So to avoid such duplicates, we are discarding this +1 and we are just assigning the value true. So if I is mentoring J, then okay, Ij value will be true. Okay. Is this clear?
Excuse me, ma'am. Ma'am, in this if statement, it is written that math mentor graph I to J. That means I is actually mentoring J. If this is true, like if it's equal to 1, that means if
Let
I
me
is
write this
mentoring
again.
J.
Let me write the whole thing again. Okay. See. We are starting with J. Okay. So J is, let's say, 001. So now in mentors dictionary, I have created one entry in the outer dictionary for 001. Correct? For them, I have an inner dictionary. This is a nested dictionary. Now for each I in rows of math mentor graph. Next I, let's say 002. So what are we checking in this condition? Math mentor graph. Ij is 1. That means I is mentoring J. That means 002 is mentoring 001. If this is true, then mentors Ji will be true. Is this clear?
Ma'am, then
Please.
why are we writing mentors Ji? It should be mentors Ij, right?
Wait. J is 001 and for J we are seeing how many incoming edges are there. That means how many mentors of J are there. So for each I, if the Ij, so I is 002 and J is 001. So I am checking if 002 is mentoring 001. This is 002, this is 001. So outer dictionary should be, yeah. So if 002 is mentoring 001, that means in the mentors dictionary for 001, I will have one entry 002, which will be true. So mentors JI. So this should be, okay, this is the mentors dictionary, na? This is not mentor graph. Mentor graph
Okay.
is IJ. Okay, mentors is different. Mentors
Okay.
is JI. Okay, that means this one has how many mentors?
Okay.
So
Yes, ma'am. Now understood.
for 001, 002 is a mentor, so true value. If 002 is mentoring 001 in physics or chemistry, there is no increment in the value. It will remain same. So in this way, for every student, I will get unique number of mentors, correct? So if I take keys of mentors 001, this will give me what? Unique number of mentors of 001?
Yes.
Sequence numbers of mentors, right, ma'am?
Yes. So length of this will be unique number of such mentors, right? That is how many unique mentors 001 has. So that is
Yes.
what is happening in the end. So popularity J will be what? Length of keys of mentors J. This same thing I've written here. Okay, in the context of 001. So
Uh,
this will avoid the duplicates. Yeah, go on.
no, ma'am. Like I just forgot my doubt. Sorry. I'll interrupt when when I get it back.
Yeah,
When I
it's okay.
remember.
You catch up. Okay. So this is clear, or do you want me to repeat? Anyone?
Please repeat it once again.
Ma'am, and could you create a proper dictionary so that it's a bit easier, like
Okay.
a bit neatly, so that creating proper examples. That's it.
All this
Now
will-
give examples for each and derive this so that we easily acceptable.
That will. I will need a
At least
bit.
one row, two row, at least marks.
Okay. Okay.
Don't need to take much marks. Yeah.
Let's say I'm taking for 3 students. Okay. So 001, 002, 003. Here also 001, 002, 003. Fine. So this type of dictionaries we have created. These are mentor graphs. Okay. I'm saying these are math mentor, physics mentor, chemistry mentor. All of them will have this structure only, right? So if 001 mentors 002, this is I value, this is J value. Okay. This is math mentor graph. If 001 mentors 002, then this value will be 1. If 003 mentors 001, this value will be 1. Rest will be 0. This is clear, right? Similar thing has been created for physics and chemistry also, mentor graphs. Okay. Now look at this. I have 2 empty dictionaries, mentors and popularity. So now in the mentors dictionary, okay, mentors dictionary, I am trying to maintain what? A list of all the mentors. Okay. Who all are mentoring a particular student? That's what I want to know without any duplicates. So if a person is mentoring a student in all 3 subjects, then also that person's sequence number should come only once, should be counted only once. Okay. So I want all such unique mentors of a student, and that information will be stored in mentors dictionary. So first, for each J in columns of math mentor graph. Math mentor graph has what columns? This is math mentor graph. Sequence numbers as the columns. Correct. So first J is what? 001. Now mentors, in mentors, this dictionary, this is a nested dictionary. So as soon as I picked the J, it will create an entry for J. So it will be mentors 001, and the corresponding value is also another dictionary. Up to this clear? This line?
Yes.
Okay. Now next, for each I in rows of math mentor graph. So if I check for 001, it will not give any result, right? 001 cannot mentor themselves. So take the next I, 002. So if this I is 002 in rows of math mentor graph. So for 001 column, I will iterate through all the rows, right? Because this is for each, inner for each. So 002, now check. If math mentor graph ij is equal to 1, what is I? 002. What is j? 001. What does this mean? That 002 is mentoring 001. Only then the entry will be 1. Yes or no?
Yes, ma'am.
Right. So if I change my graph here a little, so it should be 2 is mentoring 1. So this should be 1. This should be 0. So if this is the case, that is 2 is mentoring 1 in math, then mentors Ji, that is this is mentors J and inner I is what? What is the I? 002, and I will give it the value true. That means 001 is getting mentored by 002. Now for the same I, you will check in physics and chemistry mentor graphs also. That is this 002 person mentoring 001 in physics and chemistry also. If that is the case, then also this entry will remain same. Nothing is incremented. See, it is only assigning true value to Ji. Understood? Now let's say for the next for each iteration, inner for each, next I is what? 003. Okay. Now that's 003%. So now I has changed. I is 003, J is still 001. So I'm checking has 003 mentored 001 in maths. If not, then check in physics. Let's say this person is mentoring 001 in physics. So 003 is mentoring 001 in physics. So the value will be correspondingly 1 in physics mentor graph matrix. So mentors Ji will again be assigned true. Now what is J? This is J 001. So this entry only. What is the inner dictionary going to have now? 003 will be another entry for which also the value true will be stored, because 3 is also mentoring 1 in some subject. So like this, in mentors dictionary, we will have unique keys for all students. And for each of those outer keys, there will be an inner dictionary. Inner dictionary contains a list of all the mentors of that student, unique mentors in every subject combined. So lastly, what we will do once this mentors graph, once this mentors matrix is fully populated or dictionary is fully populated, come to popularity. Okay. So you have to check that popularity J. That means for any, let's say here popularity of 001 will be length of keys of mentors of J. Firstly, keys of mentors of J is what? This 002 is a key, 003 is a key. That means these persons are mentoring 001. They are the keys, right? How many such keys are there will be number of unique mentors 001 has. So that's his popularity, that many incoming edges. Is it clear?
Excuse me, ma'am. Actually, I have a small doubt. Like, suppose if 003 is mentoring 001 in maths, so we are creating its entry and we are saying that 003 is marked to true in this mentors dictionary. So, if 003 is also mentoring 001 in case of chemistry, and we had already created its entry for maths,
Yes,
then
then
next time.
then if you write, even if you run this, it will give the same thing. Now you're not creating
It's a
anything.
separate key value, right, ma'am?
But ma'am,
It's not separate. It is the same. You are not, see, once this is created, once Ji is created, you cannot have duplicate keys in a dictionary, right? That's why we are taking the true value, so that it remains like once we get that a person is mentoring another person in at least one subject. So that entry is fixed. Nothing will be changed, no increments.
But ma'am, like we used to check like before creating a key, we used to check if this particular key already exists. Like if this particular is a key, then we won't used to do it. But if it was not a key, then we used to enter. But in this case, we are actually not checking if
Yeah, we are
003
not checking. Now, why we are not checking? See, if I write that is key function, okay, then I have to do so for all three ifs, right? Because I don't know in which if it has become a key. In the first if, it might be that it is a mentor for math. 003 is mentoring 001 in math. So here once I have to check his key condition. Now, if that is not true, if he is a mentor in physics, so again here also all three places you must put a is key condition. Okay, if you want that is you want to check if it is already a key or not, right? That's what you're saying. So if it is a key, then obviously I don't need to write this line again. That's what you're saying, right?
Ma'am, what was the doubt, ma'am? Like, why is key
She's
coming?
saying that is like this mentors Ji. If J is mentor, if I is mentoring J, Okay, in math. Then I'm creating this entry mentors JI and assigning the value true. Now, if I is also mentoring J in physics, then also this line is written. So she's asking why I'm writing this twice. If this is already a key, if I is already a key for mentors of J, then why do I need to rewrite? This is
No,
not
ma'am.
rewriting, it will just overwrite it.
Yes, ma'am. Actually, this my doubt was that if the particular person, like if I is mentoring J in maths and like in physics, so first we entered for maths. In physics also, if I is mentoring J, so my doubt is like why aren't we checking if this is already a key and then doing like why isn't a is
Because
key
that will be
function?
an extra line of code, na? Because then you have to check both things, that whether it is a mentor and then you're again checking if it is an is key or not. So instead of writing that extra line
Ma'am,
of
I
code,
would
you
like
can
to
just
add,
write this.
ma'am, here we are not checking who is mentoring in which subject. We are checking only the popularity of people who are helping J in any three of the subjects. So
Any
we
three
need not check.
subjects, yes.
We need not check
So
in
that can
that way.
come in any, right? So it can come in maths, it can come in physics, it can come in chemistry, or all three,
If
any
they
two.
ask in which subject, then we have to do what you were sorry, telling, I
Yeah, so
guess.
there is actually no point in writing that extra is key line. Anyways, you are checking for all three conditions. Now, if in some condition this if condition is evaluates to true, then you are anyways creating the entry. Now, if after that also some condition this if also satisfies, you are not creating a new entry. This is the same mentors JI. Okay, this is not updating anything. Instead of writing
Okay.
another extra is key code, you just write this. It's like
Okay.
sort of an overwrite. Okay, nothing else.
Okay, ma'am. So it's a sort of override, and you're not creating an extra
Nothing
entry
will
for.
change. Yes, once the
Yes.
key is created, that key will remain. Nothing else will happen. No
Okay.
matter if that person is mentoring in three subjects, two subjects, one subject, it will remain fixed. That true value.
Okay, sorry, ma'am. Actually, I thought it will be written twice or
No, no, no.
thrice if.
See, keys have to be unique, right? So unique keys that if I get
Ah, yes, ma'am.
once, again 002 can't come in the inner dictionary, then it is a violation.
Yes, ma'am. Right.
Right. That's why we are creating this mentors dictionary separately so that we can get unique number of mentors for each student. Okay.
So it's a sort of updating the key value, right? Like true will be updated again and again, not
Yeah, like
not
once it
change.
is true, it will remain true. There is no false assignment anywhere, right? Because once we find that some student is mentoring some student in a particular subject, it is assigned the value true. After that, if I see that, okay, he's mentoring in some other subject also, I'm not changing anything. It still remains true. He is a mentor. That's it. I just want to know the number of unique mentors. That's all. Okay. Now, one unique mentor might be mentoring a student in two or three subjects also, but I'm counting that person only once. So this is to avoid the duplicates. Clear?
Yes, ma'am. Yes.
Everyone, right?
Yeah. Thank you.
Okay. Now, next is similar students. So, who are similar? Similar is whose marks difference in all subjects is within 10 marks. That means, let's say A and B are two students. They will be similar when, let's say, in maths, physics, and chemistry. Okay, A has scored 50 in math, B has scored 55 in math. A has scored, let's say, 70 in physics. B has scored 65 in physics. C has scored 80 in chemistry. I'm sorry, A has scored 80 in chemistry. B has scored 72 in chemistry. So all the mark differences for each subject is within 10 marks, right? So these two people can be said that they're similar type of students. They have scored similar marks. Okay. So dictionaries with marks in each subject. First we need this, again, this maths, physics, chemistry marks dictionaries. These have that sequence number is 2 marks, that key value pair. Next, this is the code. So this procedure creates similarity graph. Okay. What we are doing is we are creating a similarity graph. So we are taking all these three, okay, maths, physics, and chemistry as arguments in this procedure. All these three dictionaries. N is what? Length of keys of marks one. So you can take any length. You can take the maths marks dictionary length, physics or chemistry, because number of students are same in all three subjects, right? So N will be N only, whatever it is, whatever you take, marks one, marks two, marks three. Marks 1 is maths marks, marks 2 is physics marks, marks 3 is chemistry marks. So I can take any because all subjects have same number of students. Next, similarity graph is calling create matrix n cross n. So if there are n students, I need an n cross n matrix to represent the similarity graph. Okay. Now for each I in keys of marks 1, let's say the first I is what? 001 sequence number. For each j, let's say it is 002. If the difference between these two, we'll take the absolute value. Okay. So take the difference in all three subjects, maths, physics, and chemistry. So marks 1 IJ difference, marks 2 IJ difference, marks 3 IJ difference. This one is difference in maths marks. This one is difference in physics marks. This one is difference in chemistry marks. Okay. They are stored in IJ diff 1, IJ diff 2, IJ diff 3. Now, next, if you are checking, if IJ diff 1 is less than equal to 10, that is all the differences are within 0 to 10. That is our difference criteria, right? Difference is within 10 marks. So if for two students I and J, their subject-wise difference in all three subjects is between 0 to 10, then similarity graph entry for IJ slot will be 1. So if there are three students 001, 002, 003. So if 2 and 3 have scored, let's say, in maths, physics, and chemistry. Okay. So 2 has scored 60, this has scored 65, 75, 70, 85, 80. So difference in all three subjects is less than equal to 10. Correct. So there will be one edge between these two, IJ. So 002 and 003. Actually, this is an undirected, this will be an undirected graph. So if 2 to 3 there is an edge, 3 to 2 there should also be an edge. Right? 2 and 3 are similar students. So both of these should be having edges. Is this clear? Similarity graph?
Ma'am, could you explain the last line? Just both should have same edges. I couldn't catch that.
Yeah, I just said that this can be treated as a similarity graph since it means that two students are similar, right? So two students are similar, then if these three criteria are getting satisfied, that difference of marks in all three subjects are less than equal to 10, then similarity graph IJ will have an entry 1, right? So if 2 and 3, like I compared here, if they're similar students, so 002th row and 003th column, that means this value should be 1. But ideally, if you think like this, that if 2 and 3 are similar students, that means 003 and 002 should also have 1. They are same, right? Same comparisons will happen for these IJ.
Yes, ma'am. Okay. Understood.
Okay.
Excuse me, ma'am. Ma'am, for this difference, I think we should check for the difference should be greater than 0 but less than or equal to 10. Because when we are checking for each I in keys, so if the first key is 001,
So
for
that's why we
each,
are taking absolute value, na? So there will not be any negative. It will always be between 0 and 10 only.
ma'am, but like if it is taking for the first person, that is for 001. So it will first check with 001 only for this J in keys. So
No,
that will,
see, basically, yeah, you are saying that 001 will have zero difference between all three marks, right? So
right,
that
ma'am.
will also mean that IJ
That
diff
would
will
also
be
count.
satisfying.
Yes, ma'am.
Yeah, in that case, that this one diagonals will also have 1. So if you want to avoid that, then to do this, we should keep one more condition
Or ma'am,
that
we
it
should
should
that
be.
yes, ma'am. Difference should be greater than 0 but less than or equal to
But you
10.
cannot say that because for others also it will check. So there can be 2 or 3. These two can be two students who have both scored 60 in, say, maths.
Uh,
So that
Ma'am, I
also
guess
difference
we
is
can
within
do
10
some
marks.
procedure and remove this side effect, ma'am.
Yeah, this one you can remove. See, this is a good problem if you want. See, if I follow this procedure, then diagonals will be 1. Okay. The diagonal of the matrix will be 1 because obviously it will satisfy for
Or
all the.
multiply by diagonals into 0.
So what can you do to make sure that these diagonals are 0, that is self comparison doesn't happen? Right. So for each I in keys of marks, this will pick 001. So obviously it will again pick 001 here. So first comparison will be between the same marks. So ideally this procedure will give 1 in the diagonal elements. So how can we get 0 in the diagonal elements?
Ma'am,
Usually
can
this
we
is
use
we
that
can remove.
rest procedure that we used
Yes,
to?
ma'am. We
so
can
if you
remove.
use rest, then next iteration when you come 002 will not, when I is 002, it will not get compared with 001 again.
So, ma'am, for that, is there anything that we could actually avoid to pair like similar students? That is, diagonal should not be one. Is
That
there
means
any?
self comparison should be removed. So
Right, ma'am. Right.
comparison, what can we do? Because difference, this formula has to stay, because two different students might have also scored the similar marks. Okay, this thing, let me think a little what we can do to avoid this. I don't know, because no, here so they haven't mentioned any such thing. So here we are fine, even if the diagonals are 1, we are okay with that. But yeah, something can be done to avoid this. Okay, I'll think about this. I'll get back to you. Okay, have to see.
Okay, ma'am.
This is a good question. You also try in any programming language or even in the pseudocode. Try seeing what possibility is there that I can remove this diagonal as 0. I can make diagonal as 0. So one thing we can do is we can put one condition here. If I equals to j.
is not equal to j.
Yeah. So if it is equal to j, then we won't check anything. If it is not equal to j, then only we will check this. So this condition can avoid it. Okay. So I and j should not be same basically. So before calculating the differences, only you put one condition here that I is not equal to j, only then we are checking. Okay.
Yes, ma'am, we can do this.
This can be one way. All right. So this is pretty much it. One more thing is there in this week. I think it's lecture 9.6 and 7. Okay, these two lectures we just go through once. One is regarding the trained data set. Another is your that noun pronoun stem problem. Okay. So just I don't have the slides for those because those are just example pseudocodes given. So you go through those codes once. If you have any issue understanding, you let me know. I will explain. Or in the next class, whoever is taking will explain that. Okay, but these are the main concepts from week 9. Clear for everyone? Everything?
Yes, ma'am.
Right? Anyone who has any doubt, confusion, any part? All right. Okay. Thanks for joining then. Please join tomorrow's session also.
Thank you, ma'am.
Thank you so much, ma'am.
Thank you, ma'am.
Thank you. Good night.